Hello everyone, my name is Thomas Piana. As you said, I'm a data engineer at GitLab. And today we're going to talk about scaling processes instead of just hiring more people. And I think this is very topical, especially for a lot of people that work at smaller companies, because it's really easy to say we're hitting bottlenecks, we need to hire more people, and it's a lot harder to say we're hitting bottlenecks, is it because we're not doing things as well as we could? And so that's what we're going to focus on today. A little bit about myself. I got a poli-sci degree from the University of Texas at Dallas with a focus in Chinese politics. After that, I worked as a business intelligence engineer before ending up at OrderMyGear, which is a small Dallas startup. There I was responsible for greenfielding a data infrastructure on Airflow and Kubernetes, and that's kind of where I got my real start as a data engineer. And now I'm at GitLab helping to iterate our data infrastructure into something more mature and more stable so that we can start to do things like data science. So real quick, this is our team. Only 3 people. Top left is myself. Top right is our amazing analyst, Emily. She saves me all the time. And on the bottom is our manager, Taylor, who does a mix of analytics and engineering tasks just kind of as they come up. So here's a quick rundown of what we're going to be going over today. First, I'm going to give you a quick rundown on who we are at GitLab and what we do. It's important to have a little background on GitLab because some of our core values have really shaped some of the solutions that we've come up with. Next, I'm going to talk about our merge request first workflow. This is kind of the foundation of how we work at GitLab and how we get things done very efficiently. Next, I'm going to talk about our infinite data warehouses. And I know this sounds like a misleading title, but I promise you it is relatively accurate. And then finally, we're going to talk about scaling knowledge. And this is something that's extremely important process-wise for being able to make your data team more scalable so that every time someone has a question about data, they don't have to come find an analyst and spend that analyst time asking questions. Hey, what does this data mean? How did you get to this calculation? We need to scale that knowledge in a way that's very self-serve and doesn't take an analyst time. So GitLab is built as a product for the entire DevOps lifecycle. It takes the approach that it's better to have a single application based on convention instead of configuration. The GitLab model is the opposite of most current stacks, which I'm sure many of you are familiar with, where it's just a handful of disparate pieces that you kind of engineer together in a way that usually works. And yes, GitLab is a code repository, but more than that, it's an entire application for collaboration. So for those that are unaware, we compete in 9 different verticals currently, from managing and planning and creating, so that would be things like Trello, all the way to monitoring and security. But it's impossible to talk about GitLab the product without also bringing up GitLab the company. We're 100% distributed and believe in being as open and transparent as humanly possible. For instance, our entire analytics repo is completely open source and even accepting contributions. Just a few weeks ago, I had an issue assigned to me around writing some SQL for date calculations, and someone actually hopped in and just wrote it for me. That was amazing. Our employee handbook is also completely open and online with over 1,400 pages. I believe we have someone on staff full-time that just writes things for our handbook, so it's growing at a very quick pace. So while there are a number of values that we hold dear at GitLab, iteration is one of my favorites. Iteration is what allows us to move and adapt so quickly. This value has been a huge key for us in getting our data team to where we are now, despite our relatively limited resources. You'll see this theme come up a few times as we go through the talk. And before we get into the merge requests, here's a quick aside that I'd like everyone just to keep in the back of their minds for the rest of the talk and maybe even take back with them when they go back to work. It's the idea of incidental complexity. I was first introduced to this idea of incidental complexity by a paper about software design called Out of the Tar Pit by Ben Moseley and Peter Marks. It is kind of long, but I do suggest reading if you're interested in these things. It's very, very eye-opening. It describes the primary problem with developing software, and I think also applies to the processes that we create, which is that over time, the complexity of an application grows exponentially. Things get harder to maintain, harder to extend, and harder to reason about. This is a trap. The foundational idea is this. Your solution should not be more complicated than the problem it is trying to solve. It sounds simple on its face, but if you really get to thinking about it, it has some truly profound consequences. Engineers tend to write software that overcomplicates solutions relative to their problems. This also goes true for processes that we create. This concept of incidental complexity has really stuck with me and always assists me in making better decisions when I reframe them in which of these solutions leads to less complexity. So our first topic is about merge requests. These are the backbone of our workflow, and we've adapted the traditional CI/CD workflow to cater to our needs as a data team. Although ironically, the first slide in merge requests is actually about issues. Everything starts with an issue, whether it's a discussion, a bug report, a refactor suggestion, or anything else that might come up, it has to have an issue. Issues are a single source of truth for what we are thinking about and working on as a team. If it's not in an issue, it's safe to assume that it doesn't exist and no one's thinking about it. This stuff is pretty standard in stuff like GitLab or even GitHub or Trello or things like that, but it's very important to be strict about it. So if issues are the idea, what about the execution of those ideas? That's where merge requests come in. A merge request, also known as a pull request in other version control software I won't name, they're the smallest unit of change that we have. Anytime we want to make a change to our data warehouse, our data infrastructure, any part of our pipelines, it has to go through a merge request. We create merge requests directly from issues so that they're automatically tied to sharing the same attributes, be it milestone, weight, due date, who's assigned to it. Well, I would assume everyone with an engineering background will be familiar with version controlling and merge requests. I've anecdotally found it much less common to get entire data team buy-in on version control, and that includes data analysts and data scientists. Sometimes there are excuses, such as maybe the tools we use don't support version control, or my least favorite excuse is that it's too technical for analysts, or maybe they just in general don't see the benefit of keeping everything version controlled. So besides the general advantage of version control, why make such a big deal around merge requests? It's this right here. This is what a CI/CD pipeline looks for one of our merge requests. The key for us is that for every merge request, we have an entire review instance of our data warehouse and a CI/CD pipeline. This gives us the ability to run full pipelines from end to end, all in a sandbox. So if I make a one-line change to a model, I can run extractors, I can load it, I can run tests, I can do everything I need to make sure that when I push that change into production, nothing's going to break. This saves you a lot of time. The implications here are huge in relation to testability, reproducibility, and understanding the history of your data. This is all great, but how did we get to this underlying infrastructure? This brings us to our next topic, infinite data warehouses. While it is a bit hyperbolic, our underlying infrastructure allows us to be able to spin up a practically infinite number of data warehouses. So it was a paradigm shift for us in terms of testability and data integrity. So let's get started. Here's a meme because I was told they were required to give us talk, so I obliged. It's Oprah giving everyone data warehouses. So, in many cases, and admittedly this is just anecdata, you're welcome, data infrastructures don't have the same rigorous level of testing and quality checks as something like web applications tend to, right? The testing infrastructure for web applications and normal software is extremely robust. They've been perfecting it for, 10, 15, 20 years at this point. It's very mature. And believe it or not, as I'm sure some managers would like to believe, the reason that data infrastructures aren't tested as thoroughly is not just because data engineers are lazy or incompetent. Testing data infrastructures as rigorously as something like a web application is usually orders of magnitude more difficult. From the huge quantities of data to the heavy reliance on third-party data sources, there's a lot of stuff that we just don't control or have a hard time testing using common patterns. So that brings us to this concept of infinite data warehouses. How are we able to adapt our CI/CD pipelines to such a different tech stack? So we came up with two initial solutions to decide between, right? So first, we can clone the entire data warehouse for each branch, physically clone the entire data warehouse. As one might guess, it's not very scalable. As you start to get into the terabytes of data, it takes longer, not a great solution. But as we talked about iteration before, it's okay as a short-term solution. If you have a relatively small amount of data and it's not overly complicated, this might be a feasible solution in the short term. But then we also found out it's potentially very expensive. We personally were on Google Cloud SQL using Postgres. And as you can imagine, the more merge requests you have open, the more data warehouses you have spun up, it gets quite expensive. Solution number two, and this is a solution I've heard proposed more often. It's to generate a data warehouse that is a statistically representative sample of your real data warehouse. So benefits, extremely scalable, right? You probably have parameters, you can say how much data you want, all those kinds of things. But the problems are that it adds complexity, right? And we want to minimize the complexity that we add. And furthermore, even though it might not be as expensive in terms of infrastructure, it's expensive in engineering time, right? You have to have an engineer come up with a solution. They have to maintain that solution. They have to test it. All things that add complexity and cost. So what did we choose initially? Well, initially, we chose to go with the first iteration, our first solution here, which was, okay, as a short-term solution, let's just clone our actual data warehouse physically for every single merge request and see how far we can get. However, as we grew, we started to hit the hard limits on scalability, both for Postgres and for this workflow in general. The times to spin up those new instances took longer, it got more and more expensive, and we knew that we needed our second iteration. So if this was our skateboard, we need a scooter. For our second iteration, we found something that gave us what we think is the best of both worlds and then some. I'm sure many of you have heard of Snowflake. It's not the newest thing in the world, and I've spoken to plenty of people here that are already on it, but we're using it in a way that seems a little bit unique. So Snowflake decouples compute from storage, which is a concept we really liked, and it's stored in a proprietary format in cloud storage, AWS for us, for example, and then we can scale up or scale down our compute power by choosing larger or smaller clusters, independent of the amount of data we're storing. So what were some of the driving factors behind our decision to move to Snowflake? Well, one, as I just mentioned and you might imagine, being a cloud-based data warehouse, it's extremely scalable. The key point here, though, is the second one, which is that it has a robust metadata store, and the implications of that are very important. The first implication of having a robust metadata store is something called zero-copy cloning. So you get near instantaneous replication of almost any database object, be it a table, a schema, or even an entire database. Seems crazy, right? And there's no extra charge for duplicated data. So how does it do this? I think the easiest way to explain it is to think of it in terms of Git, right? So we've got a branch of the data warehouse, but just like when you're using Git, it doesn't actually make a second copy of all the code that isn't changed, right? It's still there. All it has to do is keep track of the diff. And that's exactly how Snowflake does it. And next, and I think this is probably going to be interesting to a lot of the data scientists in the room, is you have the ability to merge changes back into the original object. So say you're a data scientist, you have, say, table A, creative name, and it maybe has some static training data in it. But you're not happy with it, right? You want to add some more features, maybe normalize some of it, but you also don't want to change it in place in case you mess something up. So what you can do is you can make a copy of table A to be table B, another creative name. And you can make all the changes you want in table B, and when it gets to the way you like it, you can just merge it back into table A, and it'll update table A just as if you were merging a Git branch. So this is awesome, and it's this feature of zero-copy cloning that allows us to have a full data warehouse for every single merge request. So the moment you hit that merge request button, that create merge request button, we have a script that goes out and creates a zero-copy clone, which takes a minute or so, sometimes less. And then anything you run in that pipeline will automatically get pointed at that database. So there's no extra work on the part of the user. It's all handled by our CI/CD pipeline. They just do everything like normal. The second thing we have here is time travel. So the state of the database is kept for up to 90 days, and this is going to depend on your agreement with Snowflake. But one of the things we love about it, which fits in with our mantra of data testing and integrity, is that you can run a query against the state of the database right now, and then run a query against the state of the database a week ago and compare the diff of the results, right? So you can guarantee that if any of your major metrics or any of your summary statistics start to get off, you'll be alerted about it, right? It's pretty fantastic. And the only thing you have to do to make that work is just put an @ and then the timestamp that you want to run that query at. And next, and I'm going to throw web developers under the bus here. Hopefully we don't have any in here. Say a web developer somehow gets into your data warehouse. Who knows what they're doing? And they maybe make some changes that you don't like. Maybe they accidentally mess up some production data. Who knows? It's a web developer. They're capable of anything. You can actually roll back to previous versions of your data warehouse. And it could be specific objects. Say they mess up a specific table. You can roll back to an earlier version of that table and erase anything they might have done. And in line with that, if they even go so far as to drop something, you can undrop it, which I think is pretty fantastic. If you've ever worked with web developers, you know exactly what I'm talking about. So having an infinite data warehouse is one piece of adapting our CI/CD pipelines, and that really helps us streamline our process around making changes to our code base. Because you can go in, if it's something as small as a one-line change, make the one-line change, start up the pipeline, and just click a button that says merge when successful. So that way you can make that change, move on with your life. You know it'll be in the code base of all those pipelines run. If something fails, it'll alert you, it won't merge, and you can go fix it, right? That's much, much cheaper than making that one-line change, assuming you're probably not going to break anything, breaking something, spending 5 hours to figure out what you broke from that one-line change that shouldn't have broken anything, and now you're back to square one. So all that's fantastic. But the modeling and transformation steps are just as important for being able to test these changes before they go live. Along with that is the rarely talked about documentation step, where data is documented after it is modeled and transformed. So what is a data team's priority? I've been thinking about this a lot, and I try to distill it down into the simplest thing I could. The number one job of a data team is just to increase the amount of factual knowledge that an organization has available. We've gotten really good, especially I can say from the engineering side, we've gotten really good at creating pipelines, moving data around, transforming modeling. We've gotten really good at that part. But I think the part that we as an industry still lack in is documentation. How do we disseminate that knowledge to the rest of the organization? And I think a lot of people would just say, oh, it's visualization, right? I make a graph, and all of a sudden, all the knowledge that I have about this data is given to the person that looks at the graph. That's not really how it works. That's one piece of the puzzle, but good documentation is the other. And here and now, I'm coining a new buzzword. You're all welcome to use this. And I know yesterday we had ETTL, so we can meet in the middle, and it'll be ETTLD. We're going to have extract, load, transform, and document, right? Documentation should be a first-class citizen. As long as your data team has a better understanding of your data than the organization at large, the data team becomes a de facto knowledge bottleneck. So we have a 3-person data team at GitLab. We have almost 150 total employees, and we're doing our best to be a data-driven organization. That means that if we don't have documentation, every single minute someone would be coming to us saying, hey, I just looked at these slides. I'm not really sure what these numbers mean. Can you explain to me how you came to those conclusions, right? We would get nothing done, or at least Emily wouldn't get anything done, because she'd be constantly answering those questions. And like I said earlier, visualization can only get you so far, because the meaning of the underlying data in a chart might still be completely unknown to the user. Yes, revenue is revenue, but all companies might calculate that differently. It's really important to keep this in mind. So unless your data team is writing documentation around their knowledge of your data and facts, they aren't doing their part to help scale knowledge. But luckily for us and luckily for you, there is a tool that helps us with this. It's DBT, which was mentioned in the talk before this, and I think introduced very well, but it also does a little bit more than what was talked about. So it's an open source transformation layer, and for us it is the single source of truth for any and all transformations that are applied to our data between the raw tables and what gets visualized. But there are two other key areas of DBT that I think get shortchanged sometimes, one of them being testing. DBT has data quality and integrity checks built in the form of DBT tests. There are two kinds of tests in DBT. You have schema tests, which test pretty mundane things like uniqueness, not null, et cetera, things like that. But then you also have custom tests, which just asserts that if a query returns 0 rows, it's considered passing. And you can imagine how with that much flexibility, you can write some very interesting tests. And between those two testing methods, DBT can help you make huge guarantees about the quality and integrity of your data. But there's a third feature here that really makes DBT a must-have tool for helping to solve this problem of knowledge scalability. And that is DBT Docs. DBT Docs are written in Markdown and exist in the same folder as the models that they document. This co-location of models in their documentation is intuitive and lowers the complexity of writing or updating documentation when models are changed or created. On each model documentation page, we can see the details of a model, which is that wall of text my boss wrote over there, as well as column level descriptions. So we can see data type of a column, maybe any schema tests we have on those columns, what guarantees we have around that, and column level descriptions if there are any. And then, and I think this is really interesting from an analyst point of view or anyone that's a little more technically inclined, is the right side is just scroll down a little bit on this page, and you can actually see the SQL that generates that model along with the documentation. In both of its forms, I should note, because DBT compiles SQL that you use macros in, you can see either the raw or the compiled SQL that the database is actually seeing. This is huge. This means that whenever you go in to make a change, you can update that model, you update the documentation, and then DBT will run those models in your CI/CD pipeline. It'll make sure the documentation is up to date, and then it'll also test that you didn't break anything as far as the models or the integrity of the data goes. This really speeds up the process of both creating new models and updating models, as well as scaling that knowledge to the rest of your organization, because you can do all three of these things in one place. And I do believe that tests are a form of documentation, so that fits in even better. So here's one of our lineage rafts from bird's eye view on the left, and then a drill down perspective on the right. So because DBT is a transformation layer, it understands how all of your models fit together, right? So some people would say this is a DAG. They call it a lineage graph, same difference. It makes it trivial to understand when a change will affect something downstream, or if you want to make a downstream change, where you need to go upstream. And this whole UI that you've seen is completely built into DBT. Simple command, DBT Docs, it spins up a web server and serves all of this to you. So models, testing, and documentation. By having these three key features wrapped into one open source tool, DBT has become the foundation that we use with which to scale our knowledge. It is a single source of truth for all three of these things. So, now that you've seen where we are, what's next for the data team at GitLab? Looking at the hierarchy of data needs, we are just now starting to get into the learn and optimize phase. While this means maybe we are behind the curve in terms of data science amongst comparable organizations, the confidence we have in our engineering, our analytics, and our ability to scale knowledge will allow us to iterate in the data science space with more confidence. One of our key focuses as we go forward into this amazing land of data science is to hold close to our mantra of the merge request first workflow and focus on scaling knowledge. We think this is especially important seeing how opaque data science can be at times, especially to people that aren't data scientists. So here are my three key takeaways. 1, to the best of your ability, get everything in version control and do everything in merge requests. This has been a best practice in the software industry for I don't know how long, and I think it's time that data teams really take this to heart. Yes, even the analysts and even the data scientists. 2, whether by using some of the solutions that I proposed or maybe coming up with your own, figure out a way to get real production data available to test before you merge things back into production. This will save you a lot of headaches. And this is, again, something that we've seen in the software engineering industry for a long time, but we've been slow to adapt because it's not quite a one-to-one solution. And then finally, adopt the dissemination of knowledge as the touchstone of your data team. Data viz is only a small part of this. Make a commitment to good documentation. Your organization will thank you for it. Thank you, everyone, for your time.
Time for a few questions. Can you talk a bit about the Snowflake multiple version thing? I'm curious if you have, like, say, a two-step ETL, read A, write to B, write to C, and so you start with a copy of A from production, what you just second step is test against, like, the output that you're generating in this test. It's easy to do that.
Yeah, so actually, the way that we have our CI/CD pipelines built is that it's the entire database. So if we run an extract job on that CI/CD pipeline, it'll actually pipe that data into that copied database. It won't pipe it into production. So anything, it's the same. As far as the code things, anything you're doing is exactly what's happening on production. It's just happening all in that sandbox.
There is a brief caveat on that. Truncates will fuck up your time travel. So just don't get bit by that.
Yeah. Luckily, we've yet to truncate anything, so I'll stick by that.
Okay, thank you. Oh, sorry. Have you found that docs are now the first place that people go to figure something out, or do you still, does the data teams get chats all the time? It's like the go-to starting point for figuring something out and all that.
Yeah, that's a very good question. We try to solve these things with Slack bots. So the first place we found it most effective was people asking for looker credentials. So we created a bot for that and found that very effective. So we still point people to the docs as much as possible. We haven't taken it so far as to have a bot that just says, go look at the DBT Docs whenever they ask a question. But we're definitely getting there. And as DBT Docs is a relatively new feature, came out in 0.11.0, which was a few months ago at this point. So we're still working on getting all of our documentation moved into DBT Docs. But I think once that's the solution, that will definitely be what we encourage. And a lot of the people that use the data the most already, so people on like the finance and operations side, they are savvy enough, and because they're in the same organization, we talk to them enough that they've already started to understand, hey, I should probably just go check DBT Docs. Whereas maybe someone in like the HR part of the organization isn't as familiar with it, hasn't had to ask a question before, and they still maybe don't know that it exists. But it's something we're trying to get the word out on.